Hey all, today we are going to see a case study on computer applications. Let's move on to the topic.
ஸோ ஹாய் ஆல் நம்ம இன்றைக்கி என்ன டிஸ்கஸ் பண்ண போகிறோம் அப்படின்னா கம்ப்யூட்டர் கிராஃபிக்ஸ்னால் என்ன அப்படின்னு இன்ட்ரடியூஸ் பண்ணிவிட்டு அதுக்கப்புறம் அதோட அப்ளிகேஷன்ஸ் டிஸ்கஸ் பண்ண போகிறோம். ஸோ லெட்ஸ் மூவ் ஆன் டு தி டிஸ்கஷன்.
Hey team, before we dive into the advanced parts of our course, I thought it would be good to get clear understanding of what computer graphics and visualization really means. I know it sounds simple, graphics on a computer, but there's so much depth to it.
So you're right. Computer graphics is basically the branch of computer science that deals with generating images and animations using computers. So it's not just about fancy designs or video games. It's a science behind how we respect objects, scenes, and even movement visually on a screen.
Yeah, and it's involved in both hardware and software. For instance, the monitor and CPU are the hardware components that help the render image, while software like OpenGL and DirectX Unity and Blender helps creating and manipulating graphics.
They also have two types of graphics, means 2D and 3D graphics. Including 2D graphics, they have flat images, logos, and logo charts. In 3D graphics, it is great depth of data, and they are remodeled using vertices, edges, and surface. They can use transformations, projection techniques, display them to analyze the
And that's where visualization comes into effect, right? While computer graphics is focused more on creation and rendering of images, visualization helps us understand data and information through visuals. Think of a bar graph and a 3D plot of the data. Those visuals help us interpret the data better.
Spot on. So in other words, computer graphics is more about showing the world, and visualization is about understanding the world through visuals. It's heavily used in science, business, and engineering. For example, scientists use 3D models of molecules or medical scans to analyze structures that would be difficult to understand as raw data.
So I read somewhere that data visualization is actually one of the most powerful tools in analytics. A well-designed chart or graph can reveal patterns, trends, or outliers in data much faster than reading through thousands of numbers. So it's not just a pretty pictures, it's about insights.
So now we came to know what is computer graphics and how it plays a vital role in many applications. So let's move on to the real world examples of computer graphics.
Okay. Speaking of which, let's talk about some major applications of computer graphics. And entertaining is the biggest movies and games and animations. Then we have simulations and trainings like fighting simulators and driving tests, and real world behavior is short the graphical environment.
They have 3D models, interactive graphics of students. They can explore the things with solar system and human body, historical architecture without leaving their classroom. And VR is interaction between become a very more immersive.
Right, and engineering and product design benefit a lot. Let's take an example, CAD tools. This computer-aided design uses 3D graphics to allow engineers to design and test products virtually before building physical prototypes. It saves time and money.
Yeah, it's a good point, Lois. Now let's touch upon how all of it actually works. The graphics pipeline is a major concept here. It includes steps like modeling, transformation, lighting, projection, rasterization, and finally rendering the image on the screen.
Yeah, this pipeline can run either in software or hardware. Most modern computers have GPUs that are specially designed to accelerate this process. That's why gaming and rendering are much better and faster and smoother with a powerful graphics card.
Coming back to the visualizations, there are two main types: scientific visualizations and information visualizations. Scientific visualizations deals with the real-world physical data like airflow, weather, or medical images. Information visualization is more abstract, like showing company sales trends or overtime or social network connections.
And both are equally important. So one help researchers and doctors, or the other help business analytics. So tools like Tableau, Power BI, MATLAB, and VR is a same example platform used for visualizations.
Also, AI and ML are now being integrated into both fields. In graphics, AI can create realistic textures and animations. In visualization, ML algorithms help pick the best way to represent data and even discover patterns automatically.
Yeah, absolutely. Now, the computer graphics and visualization is an incredibly vast and dynamic field. It combines creativity with computation, art with engineering, and aesthetics with logic. Whether you want to build the next blockbuster game or uncover hidden patterns in data, this field has something exciting for everyone. As I conclude that computer graphics and visualization helps students to explore fundamental concepts, difference between the graphics and visualization, the real world applications, technological underpinnings, and future trends. Thank you.